Here we have a SAT math problem. Okay, let's go to the question. F of x equals to a times b raised to the power of x over n. In the function f of x above, a, b and n are integer constants. If f of 4 is equal to 4 and f of 7 equals to 108, then what is the value of f of 9? Okay, now let me take the given function as it is. In this function, let me write the given function. F of x equals to a times b raised to the power of x over n. Okay, to get the value of f of 9, we need to be finding the values of the constants a, b and n, so that we can plug in 9 for x and we'll be able to evaluate the value of this f of 9. Okay, for that we have to use the information we have over here, that is f of 4 is equal to 4. Since we have f of 4 is equal to 4, we have to plug in this 4 for x over here, and here let me do it. Then I'm getting f of 4 equals to a times b to the power of 4 over n. Okay, now let me do the same thing for f of 7 equals to 108. That is, we have to plug in this 7 for x over here and here. Then I'm getting f of 7 equals to a times b to the power of 7 over n. Okay, here we have the values for f of 4 and f of 7. The value of f of 4 is 4 and f of 7 is 108. Let me plug in this 4 for f of 4 over here and this 108 for f of 7 over here. Then I'm getting 4 equals to a times b raised to the power of 4 over n. And here for this f of 7 we can plug in this value, that is 108 equals to a times b raised to the power of 7 over n. Okay, let me take this is equation number 1 and this is equation number 2. Okay, now I'm going to divide equation 2 by equation 1. Okay, let me do it over here. That is 2 divided by 1. Okay, when I divide two equations, the stuff on the left side has to be divided by the stuff on the left side over here in the first equation. Okay, let me take the stuff on the left side in the second equation, that is 108. It has to be divided by the stuff on the left side in the first equation, that is 4, because we divide the second equation by the first equation. The same thing we have to do for the stuff on the right side. So let me divide that is a times b to the power of 7 over n divided by a times b to the power of 4 over n. Okay, here 4 goes into 4 one times and 4 goes into 108 27 times. Here this a will cancel out. I am getting 27 equals to, here we divide two terms with the same base b. Whenever we divide two terms with the same base, what we have to do is we have to take the base ones and we have to subtract the exponents according to the quotient rule of exponents. Then we get 7 over n negative 4 over n. Then we get 27 equals to b to the power of, here we subtract two fractions with the same denominator. Okay, whenever we add or subtract two fractions at the same denominator, we have to take the denominator in common, whatever denominator we have for the two fractions. And now we have to simplify the numerators, that is 7 negative 4, that is 3. Okay, now I got that 27 equals to b to the power of 3 over n. Okay, now my aim is to solve for b. So for that we have to get up this exponent 3 over n. So for that we have to move this exponent 3 over n to the left side of the equation. When I move this exponent 3 over n to the left side of the equation, then we'll have the reciprocal of this 3 over n at the exponent of the stuff on the left side. So the reciprocal of 3 over n is n over 3 equals to b. So I just move this 3 over n to the left side, it becomes reciprocal, that is n over 3. Again, it will be an exponent for the stuff on the left side. Okay, now I got the value of b, that is 27 to the power of n over 3. Now what we can do is we can plug in the value of this b either in the first equation or in the second equation to solve for a. Okay, I am going to plug in this value for b into the first equation. Okay, let me do it over here. Then I am getting 4 equals to a times. So for this b, we can plug in 27 to the power of n over 3. Let me do it. Okay, then I'm getting 27 to the power of n over 3 to the power of 4 over n. Okay, then we get 4 equals to a times 27. Okay, here we have base 27 and exponent n over 3, and for this complete stuff again we have exponent 4 over n. Whenever we have two exponents like this, what we can do is we can multiply the two exponents using the power of a power rule in exponents. Okay, let me multiply the two exponents, n over 3 times 4 over n. So here n goes into n one times and n goes into n one times. 4 equals to a times, here we get 27 to the power of 1 times 4 is 4 and 3 times 1 is 3. Okay, 4 equals to a times, we can write this 27 as 3 to the third power, and we can write this exponent as it is, because for this 27 we have written 3 to the third power. Then we get 4 equals to a times, here again we can use the power of a power rule in exponent, that is we can multiply the two exponents we have here. Then we get 3 to the power of 3 times 4 over 3, then this 3 will cancel out. I am getting 4 equals to a times 3 to the 4th power. 3 to the 4th power is 81. Okay, now let me divide both sides of this equation by 81 to solve for a. So this 81 will cancel out. Then I'm getting 4 over 81 equals to a. Okay, I got the value of a. Okay, here in the given function, I got the values of the two constants a and b. So the value of a is 4 over 81. The value of b is 27 to the power of n over 3. Okay, now in my next step, what I'm going to do is I'm going to plug in the values of the constants a and b I got over here into the function, and then I'll plug in 9 for x. Okay, now let me erase all the stuff and continue the problem. Okay, let me plug in the values of a and b into the given function. Okay, let me do it. Then we get f of x equals to, for a we have to plug in 4 over 81 times for b we have to plug in 27 to the power of n over 3. Okay, I plugged in this one for b. Already we have the exponent x over n for b. Let me write that exponent as it is. Okay, then we get f of x equals to 4 over 81 times 27. Okay, here we have base 27 and the exponent, and for this complete stuff again we have an exponent. So here we can use the power of a power on exponent, so we can multiply these two exponents. Then I'm getting n over 3 times x over n. Okay, here n goes into n one times and n goes into n one times. Then I'm getting f of x equals to 4 over 81 times 27 to the power of 1 times x is x, 3 times 1 is 3. Then we get x over 3 as an exponent for 27. Okay, now what we can do is we can plug in this 9 for x over here to get the value of this f of 9. Okay, let me do it. Let me plug in 9 for x, and we get f of 9 equals to 4 over 81 times 27 to the power of 9 over 3. Then we get f of 9 equals to 4 over 81 times 27 to the power of, so 3 goes into 3 one times and 3 goes into 9 3 times. We get 27 to the third power. Okay, then we get f of 9 equals to 4 over 81 times, since we have exponent 3 for 27, we can multiply 27 by itself for 3 times. Okay, here 27 goes into 27 one times and 27 goes into 81 3 times. Here 3 goes into 3 one times and 3 goes into 27 9 times. So then we get f of 9 equals to, when I multiply these values 4, 27, 9 and 1, I am getting 972. Okay, here I got the value of f of 9. Its values are 972.